Hello everybody and welcome to this tutorial. Today I will be talking about another set of filters that we're going to need in order to be able to analyze packets in depth and in order to minimize the amount of packets that we will capture so that we have smaller capture files that have greater precision and that will provide to us what we need exactly and not a lot of redundant information that we don't really want. In any case, I'm just gonna go ahead and select my filter here. The first thing that I want to explain is SRC and DST. So usually you will see these two keywords being used in all sorts of filters. SRC simply stands for source and DST stands for destination. It can refer to an IP, to a protocol, and in general in a Linux sort of environment, SRC and DST, those are markations for sources and destinations. They can be used as such. Anyway, the first filter that I wanted to show you is IP.src, and then you type in equals equals, and in this manner you can filter all traffic coming that contains a certain IP address. So all packets that contain a source IP address that you've specified will be displayed. Aside from that, you can also type in IP.DST. There we go. That's gonna do exactly the opposite thing. That's gonna display all the packets with a specific destination IP address. So if you want to, for example, see who is transmitting what or something like that, or who is receiving what on the network, you can use these sort of filters. Aside from that, you have a general IP filter. You can see it's the first one that Wireshark offers us. It's IP.addr, and when you do this, IP.addr is a sort of filter that is general. So all packets containing a certain IP address will be displayed regardless whether it's a source or a destination IP address. They will be displayed no matter what. Aside from the IP filters, you have port filters, which are usually used in combination with them. So ideally you want to combine 2, 3, or 4 filters and then get very specific information without any redundancy of whatsoever. So you can go ahead and type in TCP.source port. Yep, there we go. So you can use SRC keyword here as well. And you can just go ahead and type equals equals, and I don't know, you can type in whatever you want here. You can type in, for example, port 80 or 53, basically any port number that you want. Aside from this, you can also do, as we did with the IP addresses, you can type in DST, so destination port, and if you want a more general filter, you can just type in port. There you go. That wasn't so difficult. Just TCP.port equals equals and then specify a port. Aside from that, you can also say UDP dot port and equals equals as well. Now, more often than not, you will be uncertain whether something is using a TCP or a UDP protocol. So you see how we're combining 3 different types of filters here. We have an IP address, we have, well, we're not combining them yet, but you see how they can come and work together. We have, as I said, an IP address filter, we have a port filter, and we have a protocol filter. So let's say you want to make some sort of a statement in order to be very precise, but you are uncertain of certain things, like you're not sure whether it's TCP or UDP. You can do the following thing and use an expression. So you can just type in IP.addr equals equals, and I'm going to use my local IP address in LAN, so 192.168.1.2. In addition to that, I'm going to put in double ampersand sign, open up a bracket, open up parentheses, sorry, and within this parentheses I will write TCP dot port equals equals to, I don't know, we're going to use DNS because DNS has both DNS recognizes both TCP and UDP. It's compatible with both. So we type in TCP.port equals equals 53, and then we use OR notation. UDP dot TCP equals equals to 53 as well, close parentheses. Okay, so I made a bit of a typo here and I wrote udp.tcp. The field has immediately turned red. It is not allowing me to implement this filter as it does not recognize it. It is not valid. So instead of udp.tcp, which makes no sense, I will type in udp.port, and this set of rules, when applied, is effectively going to display all DNS traffic that my machine has generated. So as I said previously, 192.168.1.2 is me, that's the IP address of my machine within LAN, and my DNS server is 192.168.1.1, which is basically my router. There are no DNS records there. It just, well, maybe there's a caching process of some sort going on. I do not know, that's in the router specifications, but that's not relevant for us now. What is relevant, however, is that all the DNS traffic is more or less being forwarded from my router to my ISP provider, and then they are responding again to my router, and my router is telling my machine, is giving my machine the necessary information. The filter itself, it goes like this. So this first segment here where it says IP address, it states that all packets containing this IP address shall be displayed. Double ampersand sign simply means and then I've opened up a bracket, not a bracket, parentheses, and I've stated within that parentheses that either TCP port has to be 53 or UDP port has to be 53. If either of these two conditions are met along with the IP address, you will be the packet will be displayed. You will be able to see the packet, and then, I don't know, you can do stuff with it. I don't know, you can click on it and all this information down below is displayed. But in the next tutorial, when we actually start analyzing the packets themselves, then I will show you what all this means, and don't worry, you won't need to read any of these hexadecimal numbers. It's quite easy to figure it out, what they represent. In general, you don't need to read them all, you just need to read like a first set or something like that, and you can infer from that what it might be. In any case, I bid you farewell, and I thank you for watching. Till next time.